Howdy, math students, from Mrs. Marcellus and Gottlieb, the graphing genius. In today's lesson, we're going to learn how to create and interpret histograms. Today's learning objective is students will construct histograms by tallying data by intervals in frequency tables and graphing the results. The students will also describe histograms by analyzing them and interpreting what the graph shows about the data. Today's vocabulary is histogram. A histogram is a special type of bar graph used to display numerical data that has been organized into intervals. A histogram allows you to see the frequency distribution, or how many pieces of data are in each interval. When we use a bar graph, it is typically to show a comparison among data that is unique. For example, it might be your favorite ice cream, or a favorite sports team, or which day of the week you like best. We will use a histogram when we want to report data in intervals. For example, we might take a survey and ask people how many text messages they send each day. This data we could report in intervals. For example, we might have 0 to 99 text messages in one group, then 100 to 199, and 200 to 299, and so on. When we use a histogram, there is no space between the bars, as there is in a typical bar graph. This is because it is a continuation of data values broken up into intervals. All of the bars are going to be the same width because we will be reporting the data in equal intervals. If we have an interval that has no data in it, the frequency will be 0 and there will be no bar for that particular interval. Because everything is in intervals, we don't know the exact values for each individual piece of data. For example, in the interval that is 25 to 49.99, we know that there are 9 different remote control airplanes, but we don't know the cost of each individual airplane. Well, Gottlieb, do you have anything else to add right now? Then I think we should proceed to an example. The table shows the number of push-ups each student in Froginacci's gym class can complete in 1 minute. Let's create and interpret a histogram. When creating any type of statistical display, we need to identify the minimum and maximum value in the data set. This lets us identify what we need to include. Students in Froginacci's class can do anywhere from 11 to 38 push-ups in 1 minute. Next, we need to pick an interval. Since we're going from 11 to 38, we don't want to pick something too big, such as going by 10s or 20s, because then we won't have very many bars. We also don't want to pick something really small, such as going by 2s, because then we'd have too many bars in our graph. While there is not just one right answer, you do need to pick something that is reasonable with the data you are working with. I think going by 5s would be reasonable with this set of data. Next, we'll set up a frequency table with our intervals. In order to make things easy to keep track of, I decided to start with 10 and go to 39. You can see that I did not put 10 to 15 and 15 to 20 and 20 to 25, etc. If I did that, that would cause an overlap. What would you do with the students who did 15 sit-ups if they were both in the 10 to 15 and the 15 to 20 interval? You have to make sure that the intervals are equal. The next step is to tally the data. To do this, we will take each data value and make a mark in its interval. We'll start with 28, which falls between 25 and 29, so I'll make one tally mark there. Next we'll do 22, which goes in the 20 to 24 interval, 15, which goes in 15 to 19, 27, which also goes in 25 to 29, 11, which goes in 10 to 14, and 31, which goes in the 30 to 34 interval. I feel really confident that you understand what to do here, so I'm going to go ahead and complete the tallies. Now that the tallies are complete, we can determine the frequencies by adding up the number of tally marks for each interval. For 10 to 14, the frequency is 1. For 15 to 19, the frequency is 3. 20 to 24 will be 4. And then we will have 8. Next we'll have 7, and then finally 1. Now that we have organized our data into a frequency chart, we can create our histogram. To create the histogram, we will first need to set up our graph structure. We will have a title, and then the intervals will go along the x-axis. That is the number of push-ups done by each student. On the y-axis, we'll have the number of students. The bar height will be the number of students who can do each interval of push-ups. In order to determine that we start at 0 and go up to 9, we needed to look at our frequency. Since the frequency ranged anywhere from 1 student to 8 students, it was a good idea to go by ones on the y-axis. To finish the histogram, we will now have to draw the bars for each interval of data. In the 10 to 14 interval, there was 1 student. In the 15 to 19 interval, there were 3 students. And as you can see, in a histogram, the bars do touch. This is because we are working with intervals, and the complete set of data is anywhere from 10 to 39. I think that you get the idea how to draw these bars in, so I'm going to jump ahead to a completed histogram. Now that our histogram is completed, we can analyze and interpret it. I do want to note that the chart just underneath the title is not really part of the histogram. I just put it there so you could see where we got the bar heights. In looking at the histogram, there are lots of things we can say about the data. We could say that most of the students in Froganachi's class can do anywhere from 25 to 34 push-ups. We also might know that there is only 1 student who can do between 35 and 39 push-ups, and also only 1 student who did only 10 to 14. We can know how many numbers were in the original data set by adding up all of the bar heights, but it is impossible for us to know exactly what numbers are in this data set. Therefore, we are not able to calculate the measures of the middle, such as mean, median, and mode, and we also are not able to tell the exact range of the data set. Let's take a look at one more histogram. What does the histogram tell you about the ages of the players on Einswein's Beach Volleyball League? One thing we might note about the volleyball players is that 14 of them are between 16 and 18 years of age. Most of the players on the team are 21 years older or less. There are only 2 players who are over age 21. We also could note that there is a wide variety of ages on the volleyball league. The players range anywhere from 10 to 24 years old, so that would include both children and adults. Another thing we can do is total all of the bars. If we do this, we find that there are 36 players on the volleyball league. These are just some examples of things the histogram tells us. Unless you're asked something specific about the data display, there really isn't one right answer when you're asked to interpret it. Well, Gottlieb, it's just about time for the volleyball match between Einswein's team and Pythagoras' team to start. What do you say we head over there and cheer for them? This concludes our lesson on histograms, so auf Wiedersehen for now, math students.